start recording. Right. Okay. Welcome to DS5102 Data Modeling and Management, module. I'm excited to, see you again with this. And let's start. By the way, I'm Dr. Sampath Digalla, and I'll be responsible for delivering the whole module. So plan for today, I will discuss very briefly how and what we are going to do within this module, what are the expectations from your end, and what is my plan for delivery of this one. So you are always feel free to contact me through chat, or you can anytime you can post me for questions. Right. With that said, I expect from you, like in the previous course, continuous interactions, ask questions whenever you can give different perspective. And remember that this is very practical course and my delivery is from the academic point of view. So I know some of you are already working in these technologies. Just update us, let us know anything needs to be changed, or if you see something could be improved, right? I always welcome comments from you. Right. Mainly, if you look at the syllabus structure of this module, it focuses on, looking at the data modeling, and especially the technologies for managing different data. And what we expected from you is to develop the skills for analyzing, evaluating, modeling, and developing basically database applications. And for that, we are going to focus on two aspects here. One side, relational data models, that means relational databases. The other side is more recent, NoSQL databases, right? So the idea is we'll focus on emerging data models. Starting with the aim, I'll go back to the content. The main aim for this is we are focusing on the emerging data models and technologies suitable for managing different, types and characteristics of data. So we know now that we don't have always the data which has the matrix form where you have rows and columns, which is or tabular form, which is very suitable for storing data. So we have, semi-structured and free data, like even the text data is quite common nowadays, very exciting area. We have done some ideas we have discussed in earlier course, but, here focus on how to manage them. Right. And as students, we'll expect you to develop the skills for those. And by finishing this module, we are expected you to be able to apply data modeling and management concepts, especially from two different domains, relational aspect as well as non-relations. In most of the time nowadays, people use both depending on the situation. And you can focus also on one. It's again depend on the data domain. Second one is the design aspect. Especially from the beginning, you are going to work on chosen database application where you are responsible for designing and organizing, various data types using both ends, relational as well as non-relational data models. And you know that these two paradigms are, equally important in different domains. And one idea that I want to emphasize on is which model might be the best for your chosen application. So sometimes you can argue that, okay, relational might be better for one particular application and another for, non-relational database. And sometimes you can have a, bit of both ends. And then we also going to focus on the basic data operations like create, read, update, and delete operation. Again, in both relational and NoSQL databases, and we'll try to see the differences. And then later to the course, we are going to focus on the big data aspect, especially the huge amount of data now being collected. For example, clickstream data is one application where, when you visit a web page, they can record all your interactions with the web, which is very, it demands a huge amount of data, and you have to store so that you can actually manage them and analyze them for making intelligent decisions. Similar to that, if you look at social media data, we have various different platforms. Again, you are going to work on huge amount of data. So we are going to talk about how to store them, how to manage them, even how to handle with the security, privacy, and even the governance. So the other concept that we are going to discuss is the importance of data engineering and data visualization, especially when you say visualizations, again, very important aspect. That will be the first part in most of the cases when you are developing intelligent applications, and you have witnessed this when you're building machine learning models, for example. Right. If I go back to the topics that I'm going to handling, so today I'm going to actually have a very brief review on the relational database theory part. And then from the next week onwards, we'll directly focus on the implementations details. So that's the first part of the course. Hopefully, I will take one or two sessions, depend on how fast we can move with the practicals. Then we'll focus on the NoSQL. Again, my choice for this is MongoDB, since it's popular and also the commonly used and especially could be easily used in AI related applications as well, quite common. So we'll discuss about NoSQL database modeling and management, especially focusing on document-based data types like MongoDB. Now, that's the core two topics that we are going to cover in the course. But then we'll discuss about the data distribution, especially when data intensity applications like social media applications, people are coming, the requests are coming from all over the world, and we need to discuss about how you can actually design a system. So we need to discuss things like sharding and replication, which is the core idea behind this NoSQL type databases. And also we need to also focus on how transaction processing and consistency is handled in those models as well. So therefore we are going to compare two types of modeling models from ACID and the base from relational and non-relational models. Then we are also going to discuss about the large-scale data handling, big data characteristics, modeling, and how to manage them, different AI APIs that we can use for this as well. And later to the course and the very end, we are going to talk about in very brief, the data security, privacy, and the legal issues, especially in data-intensive applications, and data governance, social and ethical issues, biasness. For example, now we have like many large language models, and we sometimes notice that the responses coming in is based on the data that they have been trained, and the selection of the data is sometimes questionable, right? So these biasness, I think we should be aware of, especially when you're designing systems like systems based on the data. Right. So those are the basic topics that I want to cover, and this. Right. There are a few recommended texts. Actually, this is from the syllabus, and these are not just the reference. So there are more which I will post in the Moodle time to time. Um, so I will post some extra material for you to refer. Right. So that's the plan, and then um we will start basically looking at the basic introduction to the relational databases. Okay. So with that said, in this part, I'm going to talk about the very basic ideas of database management systems. You can think of as your undergraduate. It's a review of your what you generally learn in undergraduate courses. But after that, we'll talk about the modeling in relational databases using entity relationships. And then I'm planning to end the discussion with focusing on normalization aspect, which are the core uh, uh, theoretical basis for relational database models. Okay, so starting with the first one, we know that databases are meant to store data, and basically data is known facts, and then the databases are basically the collections, right? And when we talk about the collection of we normally call related data, and when we talk about the related data, it's focused on particular application. For example, if you talk about the university environment, we will have a student management system which focuses on managing our students, both undergraduates and postgraduates. So which will represent the some aspect of the real world, which is the true case, and there will be a logically organized, collection of data. Right. Now, when you talk about the database management systems, basically we use software packages to facilitate to create and maintain these data sets. Especially we call them as computer databases. And these software will supports to operate starting from define the databases. I hope you remember creating a database and creating tables inside the database with the data and relations, and actually constructing it, and also loading or inserting data. So under the manipulating databases, basically you can insert, delete, and modify data. So when you talk about both the database management system software and data self together, we normally call the database system. Right. So we already discussed these ideas of typical database management system functionality, starting from defining database, and you can construct or load the database. What I'm saying that the constructing and loading, basically when you say create the database, you are creating the structure of the database. And ideally, if it is really new data that you are going to insert, you are going to insert interactively. Or if you already have a database, maybe you are developing the system again, a new system, you have already existing system, then it will be a conversion of data from your old database to the new database. Then you have manipulating part. When we say manipulating, you can query them, you can generate reports, right? You can insert, delete, and modify them. Remember that very important aspect of the database handling is concurrent processing. When I say concurrent processing, there will be a multiple users are interacting with your database system. Now, for example, if you take social media platform like Facebook, millions of users will be interacting, insert, delete, update, so which is um, very, how to say, very complex database application. So we need to support this database management system. Should suppose support, concurrent processing. Right. Now, apart from the core functionality, there are other functionalities as well. We need to focus on the protection and the security measures. Now, for example, when you want to store usernames and password, especially password, you need to store them so that nobody can, access that. And sometimes the data also you are storing in your system should be encrypted so that nobody can read the data you have, right? Then you also have active processing, internal actions in the data, presentation, visualization on the data. So these are like other features available in database management system. Now, for example, one thing we are going to discuss in MongoDB, we are going to start, putting the server within our machine. That's one part we are going to do. Then we are going to discuss how the MongoDB server can be handled. And with the software like MongoDB, they have what we call the Atlas, which provide this cloud, interface. We can also visualize the data. So it's not just the data. Sometimes even the database performance can also be visualized. So there are features provided by the database management systems as well. Okay, right. So few things normally we discuss in a database environment. So in this diagram, simplify the database system. That means, database management system software, data, and also the different types of users interact with your database. So in this particular case, you can see on the top, there are like different types of users are interacting with the database, right? So starting from the basic users, entry level, management users, administrators, so comes under this, right? That's why it says users and programmers. So there are people who uses this, there are people who actually develop this as well. And how they interact with the database system software through application programs or its queries. So if it is a general user, it's through some applications program, right? So it's like you have some interface, sometimes we call front end, and then the database will be in the back end, right? Or else if you're a programmer, you can directly access database through queries. This is what actually I'm going to discuss within the course as a developer, right? How do you interact with this? And we will learn writing queries in both ends using relational databases as well as non-relational databases. So we are using both MySQL and MongoDB. Through queries, we will learn how to interact with the data. So remember that the focus is also design and the development of the database aspect. So we are going to focus on that. Right. So under the database management system software, you have software to process your queries. Remember that these application program queries here need to be converted so that actually you can access the data directly. So when you see the data, you will see there are two types here. So your actual data as well as data about data. For example, in a typical database system, you have a structure, that information, and also you have the data stored in this structure. So these are the two types you will see here. Right. Then we normally talk about the data models and the model operations. So ideally, different concepts that we discuss about the describing the structure of the database and also the constraints. And the database model operations means the operations for specifying database retrievals, updates, related to the particular data models, right? So ideally, when we talk about the data models, we normally talk about the three types of data models: conceptual level, and then physical level, and then implementation level, right? So conceptual level, very high level one, entity base. For example, ER diagrams that you have drawn is comes under the conceptual data models. And the physical level means like how actually the data is stored inside the computer. And the implementation means in the middle of this, right? So that's what it says, it falls between these two. Right. Then you have schemas and then you have instances. So starting with the database schema, basically it will be the description of a database, right? Its structure and whatever the constraints. Now, for example, uh, when we talk about the schema diagram here, which will shows you data requirements in a university system, starting from the student, course, prerequisite, sections, grade report, and so on, right? And then if you take a particular data that you are going to store, that will call the instances. So when you say database instance, so this will be the schema, the structure that we did discuss. And the actual data will be a particular instance. Why we are saying particular instance here is database always change, because you add the data, new data, you change the data. So therefore, if you take a particular moment, so that moment we normally call a database instance. And then you have database states, right? That when you say a particular moment in that case, we can say database state. So what I mean by the state here is that, for example, when you just create the structure and when you first insert the data, right? So that means the initial stage, as I told you earlier. So if let's say you are developing a database systems and you already have some data, so what do? You start with creating the structure and then you load the data. So that is what we call the initial database state. And ideally, it should be a valid state, right? Because you have various different constraints we are going to define. For example, let's take student registration number. So simple constraint could be that it should not be a null value. Null value means you have to have some value there. You can't have any missing values. So it's a very simple constraint, right? Or else another constraint could be the range of data that you can have in a particular column. For example, we can say the age of a person could be between 0 to 120, or marks should be between 0 to 100. Right. So ideally, schemas, the meaning, the structure, very rarely we are going to change. So therefore, we can say schemas will not change. It's very infrequent. But the database states usually change every time. Whenever you insert, whenever you change, whenever you delete, it will be a new database state. Right. So when you talk about the three schema architectures, ideally we talk about the database management system into three levels. So we have internal schema, that means physical storage structures and access path. Remember, you talk about something called indexing, how you actually store the data when you want to access a particular piece of information, right? So they use a physical data model. Conceptual schemas in the very high level, it will describe the structure and the constraints, right? And it uses either conceptual or implementation data model. Then you will have external schemas, external level, various user views, right? User view means like you might have, data separate into, let's say, tables. but you can combine some of them together. For example, we can keep the students and their courses together as a separate view. Right. So in this diagram, basically briefly talk about the three schema architectures. So whenever you make some changes, right, you have external level, you have conceptual level, you have internal level, and in between you will have a mapping, right? So here we have external to conceptual mapping, here we have conceptual to internal mapping. So we talk about something called data independence. You can change the conceptual schema without having to change the external schemas. You can change conceptual schema, but you don't have to make any changes to external. So this is called logical data independence. Physical data independence, you can change the internal schema without having to change the conceptual schema. Now, let me give an example. In this particular case, you can change the index, right? So for example, let's say we have a student table, and let's say you have created an index for registration number. So what happens whenever you want to find a student based on their registration number? It's quick because you have create a storage structure so that you can quickly map where it is actually stored. But you can change it. Let's say instead of registration number, you are going to use the student's last name, and that won't affect your conceptual schema, right? So you can change the lower, and you don't have to worry about the upper, right? So that's the independence idea. So the independent idea here, what it means is you can change the lower level, but you don't have to really worry about the changes. Only mapping you might have to change, right? So application programs need not be changed. Right. Then under the database management system languages, there are many different types of languages we use. Data definition languages we use to specify the conceptual schema, right? Ideally, the views. Then we will have separate storage definition languages, specifying internal schemas. View definition languages we will use to define internal and external schemas. Right. Most commonly used one will be the database, data manipulation language by using like commands, right? We can use and we can embed them, right? And you can use standalone data manipulation commands directly. So for example, let's talk about the SQL, which is what we are going to use to retrieve usually in relational databases. So one way is you can directly, access the data just using SQL, or you can use embed them with whatever the programming language you use to develop the application. So these are the two things we discussed here. Right. Here is the same diagram that we have seen earlier, simplified one with more detail, as a diagram. What is exactly happening inside? I'm not going to explain everything here, but let me pick a few ideas. For example, previous one we discussed about the different types of users, and here it will show you those different types of users here. So you can see that those who are working on the database itself, database administrator staff, application programmers, and those who are users, we have casual users and parametric users. And then how exactly they are, what application programs they are actually going to use to access the database management systems. As a database administrative staff, you are using DL statements and also any privilege commands. Application programs, they use application programs to access the data. Parametric users mean general users. So those who are developing the application, they have already developed well-tested transaction we call canned transaction or compiled transactions. So these are the general users. Usually they will allow you to use what is already tested, canned transaction. Now, for example, if you go to ATM, you know that when you want to retrieve, there are ways that you have to actually, operate in the ATM machine. So the commands, there in the interface is called canned transaction. They are well tested. But let's say the casual users, for example, they can use an interactive query. For example, top managers, they can, directly access their data, right, in their customized queries. Right. So this is what normally shows you what is happening in the database management systems. Different users use different ways, but ideally it will be map it to the language that database management system understands, and then you have to get the required data from the stored database. Right. Database system utilities. Usually when we work with the database management system, there are various functions we can perform, starting from the first, the loading the data. Right. When I say loading the data, it might be like just inserting records one by one, or maybe just directly load the data from some text files. Or you are going to get it from another database and maybe you use some conversion tools. Second, ideally, when you're working with the databases, you need to back up the data. Reorganize the database file structures, report generations. Okay, these are like general work. But of course, if your database management system is performance critical application, of course, you need to focus on the monitoring the performance of the database. And there are other functions as well. Right, now that we briefly discussed about the database management system or the structure, the different types of users and different ways of accessing this. So let's look at the typical database design methodology. Right. Now, ideally, like software development life cycle, so you will find the information system life cycle for in database application as well. Right. And ideally, the database usually will be a part of the information system. Right. So we know that traditional waterfall type software development, you start with the feasibility analysis and requirement analysis, design, implementation, validation, deployment. These are usually, you will find a waterfall-like structure. And remember, the database will be a part of it. So in database design lifecycle, also you have the system. Similar to the life cycle you see in the software development, you will see the similar life cycle in the database development as well. So in the beginning, you have to you have to define the system, which means that you have to identify the scope of the database systems, different types of users and the application. Then you have to design it. And when you're designing, usually you have a logical design, physical design, and that's actually based on the chosen DBMS. Remember that in beginning, when you're starting with the conceptual data design, you are not going to focus on a particular database. But of course, and after that, right, you have to focus on a particular database, and based on that, you are going to make a design. And that is exactly what I want to discuss. I want you to identify the difference between the relation and non-relation. Then we have database implementation, specifying the conceptual, external, internal database definitions, creating an empty database files, and also implementing the software applications. So in database lifecycle, you will see the loading or data conversion. This is what happens here is the populating the database, then application conversion. So you have to convert applications to the new system, testing and validation, operation, which means you are running the system. Then you have the monitoring and maintenance. So there'll be two parts. You have system maintenance as well as performance monitoring. Right. Now, what is the problem that we are trying to handle in the design process? So we need to design the logical and physical structure of one or more databases to accommodate the information needs of the users in the organization for a defined set of applications. Now let's take an application of student management system in a university. So why do you need to create a management system? Because we know we need to keep track of information about the users. So you enter a university, and then you spend some time, and then you are going to leave. So we have to keep track of all of your information, right? In a logical way. So we need to design it. We have to design what information we are going to store, in what way. So we have to define the structure. So depending on that, we might have to create multiple databases. Okay, one database for student information, right? Handling only student information. Financial information, maybe another different database for that. Likewise, you can decide on the different types of databases to handle that problem, right? For example, for students, we can have one database. The staff, we have another database. So likewise. So the goals of this is to satisfy the content requirements, provide easy structuring, and support the processing requirements. For example, now processing requirements and the performance are related to each other. For example, we can say that, okay, how many transactions we need to complete for a particular given time per minute, for example. So those are also should be stated when you are designing. Right. So phases of database design and implementation, you will have requirement collection and analysis, conceptual database design. So that in here you collect all the requirements here. For example, the requirements of the users, requirements of lecturers, requirements of the courses conducted by the lecturers and so on. And then you develop the conceptual database design, like ER. So you define entities and their relations and what type of relations you have. One-to-one, one-to-many, many-to-many, and so on. Then you have to choose a particular database. Then only you have to go for logical databases and then also physical database design. And finally, you will have a database system implementation and tuning. Right. Now, the ideas that we have discussed here, you can see as a graphic. So you will see the different phases. So you can see like two phases here. Sorry, two different aspects here. So we had the phases similar to information system development for database system development, starting from requirement collection, conceptual database designing, choosing the DBMS, data model mapping, physical design, and system implementation and tuning. And here we can see the data content structure and constraints. So you start with getting the data requirements, conceptual schema design, and remember that this is the independent of a particular database. So it's called database management system independent. Then you will have a logical schema and view design. But remember that this will be depending on the chosen database management system. Then you have internal schema design, again database management, DBMS dependent, and then you have DDL and SDL. And the database application also comes in parallel to this, right? This is about the data, but here the database application perspective. So you start with the processing requirements. For example, how many users are allowed to access your database? How many users can, work on this, right? Updates the database, concurrently and so. Then you have to design on the transactions. So the transactions means that when you're doing a particular task, you have to work with multiple, data items. For example, let's say you are going to withdraw money from ATM, which means that you are going to, you have to deduct the amount of money you want to withdraw from your account as well as bank accounts. So there are like, you are running multiple things. So if there's a failure, either you are going to, execute everything or execute none. Because what we are expecting is a valid database state, right? And finally, you will have transaction and application implemented details. But you have a cross requirements here. So here we will come from here, frequencies, performance constraints together that we see here internal schema design. And with the transaction application implementation, we have logical schema and view design. Right. Okay. Now we have discussed about two parts here, right? The first part we discuss about the database management system. We discuss about the database, what we expect from the database management system. Next, we discuss the database design, especially the life cycle, right? So now under that, we discuss a very important phase is data modeling. So this part, I'm going to focus on the data modeling, and really remember that this is about the relational data modeling, right? So this is about the relational data modeling. Right. Now, in the relational data modeling, in the conceptual schema, especially what we discuss is in the relationship diagrams. Of course, there are many other. You can go for class diagrams, for example, UML, using UML, that's also possible. But as a common tool that everybody uses, I'm going to focus on the data modeling using ER diagrams. Now, I told you the first step would be the requirement analysis and getting or collecting requirements. And here is a simple description about a simple database application. So this is called a company database application. Okay, so you can see the description are written in text, and you can see some highlights here. So these highlight information, I will explain what those are. So time to time. So this will describe basically your database requirements, right? So let's read out with the first one. It says the company is organized into department, and then you have name, number, and we have an employee who manages the department, and we keep track of start date, and then you have several locations. Okay. So, for example, if you look at the data requirements, you see that here we have a department, and we want to keep track of department name and department number. Similarly, if you read the second one, we have a department controls number of projects. Each project has a unique name, unique number, and it's located in single location. So you can see that. So there are some data requirements like name, like number, so which will describe the projects. Then we have employees. We have name, social security number, address, salary, sex, and even the birth date. So these are the these are the facts that we are going to store about the employee. And then we have other information like they works on one department and may work on several projects. And we keep track of number of hours per week that an employee currently works on each project. We also keep track of direct supervisor of each employee. Last one, each employee may have a number of dependents. For each dependent, we keep track of their name, sex, birth date, and their relationship to the employee. So you can see that we have gathered their data requirements as a description, right? And each and everyone is talking about a particular object in mind. So this is what we call entity in entity relationship diagram. So you can see those who are in uppercase letters: department, project, employee, dependent. So these are known as entities, and these others are known as attribute, which describe the entity. Right, now starting from here, what we want to develop is a small diagram, graphical representation, to identify what are the entities and their attributes, and then their relations. Okay, so this is a graphical representation of the previous one, the description as a graphical element, and this is called conceptual diagram of the company database. And you can see we are using different symbols here, right? So you can see entities are represented using the rectangle boxes. So what are the entities? We have employee, we have department, we have project, right? And here also we have double lines, which means the idea of dependency here. What it means is without an employee, there's no existence for this particular entity type. So therefore, this you'll use double lines in the rectangle. So single line, we have entities, double lines we call weak entities, right? Then we identify their relationships. What are the relationships? We normally call, we have employees, and then employees works for department. So each employee works for one department. So the works for is actually specifying the relation between these two entities. So this is called relationship. And you can see it's many to one, meaning like one department can have many employees. Employee can have one department. Right. Now, similar to that, if you read here as well, we will also say something that here, an employee who manages the department, again, we talk about a relationship between the employees and the department. So that is also represented here. So here we have employee and department, and the managers is a relationship. And if you take a particular employee managing a particular department, and the department is managed by one employee, right? And then you can notice here as we keep track of start date of the department manager. Because of that, it relates here. So this attribute is related to this relationship. Right. Similar to that, if you look at another relation, we have employee, we have projects, and employees works for many projects. And a project can have many employees. So you can see this is many-to-many relation. So the number of hours a particular person works for a project is attached here. Right. And then if you go further, for each employees, you have supervisors. So what it means is you can see we have a supervisor, again, relation with the same entity type, right? So that's why we have recorded their roles here. So here we have supervisor, and this part is supervising. So if you take one particular employee as a supervisor, can have many supervisees. So you have many here. But if you take one supervisee, you will have one supervisor. So as you can see, in here, we will see the ER model, and it will show you the entities. So we see the entities here. right? And then all the relationships and the attributes which will describe these entities. So you can notice here, employee, we have a social security number, name, birth date, sex, address, and salary. So which describes this employee entity type. And if the values are unique values, you usually underline them. Unique attributes are underlined. And you can have multiple. For example, department. You have a unique number and unique name and unique number. So we will say here, in the department, you have unique name and unique number. So you can see both are underlined, which indicates that they are unique. So here also we have project, again, described using name, number, and location, and both are we call unique one. We call key attributes. So the key attribute for employee is social security number. Key attribute for department is name and the number. Key attribute for project is name and number, right? And here we have relationship. For example, if you take works on, employee works on projects, and project, you have employees. So you can see this is many to many. What do you mean by many to many here? If you take one particular employee, employee can work for many projects. Take a project, there will be like many employees. Right. So in this one, it will show you all the graphical representations for ER diagrams. So we already discussed entity, weak entity. Okay, relationships, we have diamond shape blocked. So we have works for relation, managers relation, and works on relation. And if you have like double rectangle like this, which means identify. So when you have a weak entity type, here dependent is weak because you don't find a key attribute here. So we have a partial attributes name, it's not unique. So therefore, this will be a weak entity type. And then through this relationship, you are going to connect to the main one, which is employee. So therefore, the relationship is also weak. So this, we use a special name for this. We are calling identifying relationship. So through the employee, right, we are going to identify this. So for example, when you want to find a primary key, for example, when we create a table, you have to consider the primary key of the employee as well as the partial key here. Together will form the primary key for the dependent. Right, then there are other symbols as well, attributes we have observed as you have ovals, key attributes, you underline them. Okay, if there is any attribute with multiple values, for example, color of a cloud, assume that you have more than one color, then you normally use double ovals, which will indicate multi-value attribute. Okay, so here we have departments can be located in multiple places. So you can see it's an attribute, it's a multi-value. Then we have composite attributes. So usually when you have a situation like this, when you have a name has multiple parts, this is called composite attribute. Similarly, address can also consider the composite attribute. Right. Finally, total participation and partial participation. What I want to emphasize here is we can identify the types of relation, whether it's one-to-one, one-to-many, or many-to-many. So that means the maximum participation. Now, for example, if you take an employee manages the department, take one employee, manages one department. Take a department managed by one employee. Similarly here, if you take one employee, works for one department, a department can have many employees, right? That is what we call the maximum kernel. The minimum kernel, we call, total and partial. So partial means not all the entities are participating. Total means all the entities are participating. Okay, for example, let me take an example. If you take employees, not all the employees are managed in departments. Some of them, this is optional. So therefore, this is a single line. But if you take a department, department should have an manager. So therefore, this should be a double line, right? So this is called maximum and minimum. So here we have minimum cardinality, right? Okay, so now just to summarize what we have discussed here, we discussed about the database applications and the modeling aspect using ER diagrams. When you want to draw the diagrams, these are some guidelines. Again, this is coming from the Navate's book, which is commonly used in an academic domain. But you should follow some kind of a guideline when you're developing this. So Navate's book recommends these guidelines. So they say one thing is ER diagrams represent the schemas, meaning the structure, not particular instances. And it also says that use singular names. For example, we talk about student, employee, department, and request to use uppercase letters if you're using for entity types and relationships. So you can see employee, it's entity, and then written in uppercase letters. Works for, on the other hand, it's a relationship type, again written in uppercase letter. But if you go for attributes, they request to have them capitalized, like name, like salary. The starting letter should be capital. If you have recursive relationship, you have to use role names and use lowercase letters. So recursive is the relationship is with the same entity, but then you have to define the two sides and then use simple. Then cardinal ratio, that is what we call the maximum participation we have to represent. So 1 to 1, 1 to many to many, and so on. Then participation constraint, total and partial. You use single line or double line. So single line indicates the optional one. So not all the employees might have dependents. Not all the employees works as managers, right? Not all the employees works as supervisors, and not all the employees, being supervising. So they call the optional, right? So if you are asked to develop a diagram like this, and if you cannot identify all the required details, then make sure that you make necessary assumptions. Right, now let me talk about a little bit more on here. Ideally, we talk about ER diagrams, but the problem with the ER is it will not support specialization and generalization ideas. So let me briefly discuss about the extended, or what we call the EER model. So the difference from the ER to ER is you are going to incorporate set subset relationship, specialization, generalization hierarchies, especially very useful, right? When you want to represent hierarchies in the data. Right, let me briefly discuss the ideas here. The first one is we are going to have more concepts in enhanced version of EER. So what are the additional concepts? We are going to talk about the subclass, superclass, specialization and generalization, categories, attribute inheritance. And the outcome of this is known as enhanced ER or extended ER, or in short, we say EER. So the idea is if you need the hierarchies in your data, this is very, very useful, right? Especially this includes some object-oriented concepts. Right, let me start with this first. right? This one shows you specialization. So you will notice here employees, and you are going to identify here superclass subclass relations. What I want to show you here is sometimes when you are going to create employees, there could be, depending on their job types, we can have employees as secretary, technician, engineer. So the difference will be you will have special attributes only belongs to those subcategories, right? So you can notice here. Generally, employee has name, social security number, birthday, address, job, and so on. But then again, if you take a particular specialization, right, that means subclass of employees, you can see special attributes like typing speed, only relevant for secretaries. Technician grade, only relevant for technicians. Engineer types, only relevant for engineers. So this will show you, use of that idea. And this is how we are going to represent. Usually you will see a circle between the superclass and subclasses, right? And then this line indicates the relation. And you can see a small arrow-like shape. This will indicate superclass to subclass. So always this arrow we specify for the towards the subclasses, right? So this will indicate this will be the superclass and this will be subclass. And the subclasses are created based on the job type. Why we put job type here? Because you can have many configurations like job type. I'll come to another example where I will show you here. Then there will be a letter indicating whether they are distinct or whether they are overlapping. Distinct means that if you take a particular employee may belong only to one of these. So if you take a particular instance, it might belongs to secretary, technician, or engineer. There's no overlapping ones, right? It's called distinct. That's why you have a D here. Right. Let me get another more complex one. Now I told you that this superclass subclass can relation is based on something. So in this particular case, superclass subclass relationship is based on the job type. But of course, you can have other classification as well. Now, for example, if you want to create a superclass subclass relation based on how they are paid, right? So we can have two subclasses: salaried employees, which means that permanent employees where you get a salary at the end of the month. And then you can have a set of employees who are contract basis and they are get paid hourly basis. So this is another, superclass subclass relationship. Here is another one. Simply you can have another separate one based on managers, right? And you can see here also single lines and double lines. What I mean by that? Now, single line indicates the very same idea earlier, that not all the instances belongs to these subclasses, which means that there could be some employees, right, who are not belong to any of these three. So there could be someone here. This is also same. We know that only some of the employees works as managers. Others are here. But this one is double. What do you mean by that? If you take all the employees, they are either salaried or hourly employees. That means they are permanent or they are contract. Right. Another interesting point that you will notice here is these subclasses also have relations. Right. Okay, give me a second. Okay, we have been discussing about the conceptual data modeling, and then we discussing very briefly about the ER diagrams, and we have been discussing about the extended version of ER, especially representations available for representing superclasses and subclasses. Okay. So what I want to highlight in this diagram is actually representation of superclass subclass relations. And then you can have different superclass subclass relationship with same entities. Here we have superclass employee can be put into three subclasses as secretary, technician, engineer. And remember, this single line indicates that not all the employees are, put into subclasses as secretary, technician, engineer, which means that there could be some instances where they comes under here. Similar to the manager relation, in this one is subclass is manager. And it's again a single line indicates that only some of the employees comes under manager subclass. And here we have double lines, which indicates that all the employees here, all the instances of employees are either salaried employees or hourly, employees, which means permanent and contract. The other one is when you have subclasses, they might have their own relations. So here we can have manager, and manager manages the projects. It belongs to this. And similarly, contract basis or the hourly employees, you can say belongs to, they might have trade unions. Right. Okay, let me show you another example. Now, in this example actually shows you how you might actually create, superclasses from subclasses. So in this example, we'll show you like, okay, you start with two classes, car and truck, and you see there are some attributes are common. So when you have a situation like this, especially when you're creating entities, if you see that there are like common attributes are shared among two different entities or entity types, what you can do is you can put into a superclass subclass hierarchy. So what you notice here is, so here the common ones we identify and create a superclass called vehicle. And the common ones are pushed upwards. So you can see vehicle ID is common, price is common, license plate number is common. And this will belong to the superclass vehicle here. Now, since these are subclasses and using subclasses, you form the superclass, this will be a double line always. Why is double lines? Because all the entities are here sharing common ones, because they are going to put common ones, we are going to put into the vehicle, right? And so the superclass subclass relation is distinct. That means if you take a particular vehicle, it will belong to either car or either truck. So this arrow-like shape is going from superclass to subclass. Right. Another example. In this particular case, if you compare our previous diagram, you will see a slightly different, symbol here. You see O, which indicates overlapping. What I mean by overlapping is when you take a particular instance here, could be manufactured part, could be a purchase part, or could be both. It's, that's why it's called overlapping, right? It's overlapped, right? So when you have a overlapping, so when you take a particular instances may belong to both of these subclasses, right? So you can see here, we have part as a superclass, then it could be a manufactured part, it could be a purchase part, or it could be both, right? So when you have a situation like this, so the symbol we marked as O, which indicates overlapping. Right. Last one, to describe this, especially when you have, there are some situations we need to see not a particular superclass, right? Representation in the relation. Now, in this particular case, I'm going to start with here. So in this one, you can notice it will be entity type. It's called owner. And we have a vehicle, registered vehicle. And owners owns registered vehicle, and it's many to many, meaning like a owner can have multiple registered vehicle. A vehicle can be owned by multiple owners. Right. Now, interesting point comes here. So the arrow is in this direction, which indicates that these are superclasses and this is a subclass. So remember that in this particular case, owner, what this is union we call, this is called union type, which indicates that the owner could be one of these. You know that when you're purchasing a vehicle, you can directly purchase a vehicle, or you can put into a bank. Through a bank mortgage, you can purchase the vehicle. So owner will be the bank, or sometimes it could be a company, right? So this will indicate that, so your superclass could be a person, or could be a bank, or could be a company. Now, similar to that, you can put in the other way around as well. Now, for example, think about this. Your registration vehicle could be, right, a union here, which means that it could be a car or it could be a truck, right? So in that way, so we can representation, here the subclass and here the superclass relation. So for a given time, only one of them will, so when you take a particular instance here, it might belong to one of these, right? So that's the idea that when you want to represent. Right. So that is about the enhanced or extended version of ER diagrams. And what we need to summarize is these ideas could be used to represent superclass subclass relations, which is sometimes very useful when you're modeling databases. Now, the next one is once you have learned the conceptual model, you have to define the logical modeling. Now, when you take over the logical modeling, we know that our entities should be mapped into relations, right? Map into relations. So when you are going to map into relations, the previous our ER diagram can be mapped into multiple relations. And then we can have relationships between all these, what we call the schemas, right? So therefore, we need, in this earlier, we have all the entities. Now we make it to relations. And then we will identify primary keys and foreign keys. So this is how we will model in relations. And that next, you can look at one possible states, right? Okay, so now we are going to discuss how do you map this, starting from ER diagram into a logical diagram like this. And after that, you can actually convert them into tables using SQL, which we are going to discuss in the next session. Right. Okay, let me discuss the mapping now. Now that we have understood about the graphical representation, right now let's see how we should map given a ER diagram. That means your conceptual model. How do you map it to logical model? Right. So here is what we are going to discuss. We'll start with the entities, then the relationships, and then multi-valued and n-array relationships I will explain. Then I will discuss about the things related to enhanced or extended version of ER, that is specialization and generalization and union types. Okay, now given this one, what we want to get is starting from entity types and the relationship types, we are going to create relations, and that's what called the relational model. So therefore, this is known as relational model mapping. So let me discuss how to, get into from conceptual to relations. Okay, basic ideas. From starting from basic ones, you already know. So therefore, let me brief on what we need to learn. With entities, especially, all the regular entities, you map it to relations. So therefore, in this particular case, this is a regular entity, this is a regular entity, this is a regular entity. We have 3 regular entities and 1 weak entity. We call entity types. So all these 3, we will create relations. So you will notice here, we have employee, right? We have department, and we have project. And you have list all the simple attributes and take 1 attributes as a primary key, and you underline this. So take the employee. So what are the simple attributes? We have birth date, social security number, first name, middle initial, last name, sex, address, salary, all the simple attributes. And we have only 1 key attribute, and we take this as a primary key. So you will see here, right? Similarly, if you take the department, we take the simple attributes, that is name and the number, but take only 1 of the key attributes as the primary key, right? So the department, we have department name, department number. So only 1 of them, remember, primary key, we have 2 key attributes, but we take only 1 of them as a primary key. So you see, we take the department number. Similarly, go to the project, we have name, number, location, and we are going to select 1 of these as the primary key. So we have project name, number, location, but we'll select this as a primary key. So that's the first step, converting your regular entities into relations. Next, weak entity. This is a weak entity type. So similar to previous, again, you list down all the simple attributes. But to create the primary key, you have to get the primary key from the employee relation plus name. Together, you create the primary key. So therefore, when you take the dependent, you will notice you will have name, sex, birth date, relationship, all the relations. But social security number actually coming from the employee relation. Combining these 2, you create the primary key. Right. So that's about converting entities into relations. Next one is your mappings. That means one-to-one, one-to-many, and many-to-many. Now, we'll start with the one-to-one relations. So when you have one-to-one relations, you can actually take multiple approaches are there. So you can use either foreign approach, right? Foreign key approach, or you can actually create a separate relation. So what are the one-to-one relations we have? Okay, we have managers here. That means employee manages department, and then the department, you have employee, right? Now, 2 possibilities in the foreign key approach. You take the primary key of the department, you put it to the employee, or you take the employee, you put it to the department. Okay, simple question for you. Which path I should take? Should I put the employee social security number in the department side, or we should take the department number in the employee side to represent the manager's relationship? I will repeat the question. Like, I want to identify how to convert this manager's relation, right? This relationship type, we need to map it to relational model. To map this manager's relation, It's a one-to-one. And we are going to discuss the foreign key approach. When I say foreign key approach, what we do is we take a primary key and put in the other relation. Now, there are two possibilities. What are the two possibilities? You can take the employee social security number and you can put in the department side, or you take the department number and you can put it the employee side. My question was, which one is the best approach? Right. Right. We were discussing about converting managers relationship into a relational model, and it's a one-to-one relation. And there are two possibilities. What are the two possibilities? First one, the department number, it's a primary key of the department, can be put into the employee side, or social security number put in the department side. If you take the first answer, that's okay, you can use it, but think about this. Not all the employees works as managers, right? So what happens, right? What happens, right? There'll be a lot of null values. We will have several departments only, maybe 4 more, maybe 5. If we have 100, all the remaining will be null values, right? Isn't it? But if you choose the second one, think about this one. Whoever the manager in the department should go into this side, right? His social security number comes here. Manager's social security number is with the department side. And this is total participation because of that, right? All the department, you will have a manager, right? So the best answer for in this particular case is second one. That means we take the social security number and we put it in the department side. Since we put it here, right? I'm not going to use many. I can say manager social security number, and then so that means I should put here the correct answer or the best answer. I'm not going to say correct because you can think of one as well, but I told you already the problem is. Since you are putting here, whatever the attributes belongs to managers also should come here, right? So we can say manager start date. Hope you understood this, right? Actually, there are three possibilities in general one-to-one relation. What are the three possibilities? One is foreign key approach. That's what we have discussed. Or you can have a separate relation which combines the two. Or you can merge them if both participation is total participation. So make a note of these three possibilities if you have one-to-one. Maybe I will give you a note. I have removed that note from the note, but I will give it to you back so that you can go through it. So if you have one-to-one relations, right, there are three possibilities. You can have foreign key approach, you can have a separate relation, or you can merge them, right? Make a note of this, right? Anyway, that's good. I think it's good that we cleared any doubts we have. Right, next one. We will have one-to-many relations, right? When you have one-to-many relations, so what is one-to-many? Okay, so here we have one-to-many relation. Works for. Again, let's look at the foreign key approach, right? So if you're going to represent this relation one-to-many, and if you take foreign key approach, again, similar to previous, we have two possibilities. What are the two possibilities, right? We can take the employee social security number, we can put in the department side, and we can get the department number, we can put in the employee side, right? This is works for. If you use works for, which one is the best one? So what you do here in this one is you take the department number, right? So therefore you take the department number, put in the employee side. So here we can put, right? Here we can put department number, right? So that all the employees you are belong to a particular department, isn't it? So therefore you put it here. What if you put social security number in the department side? For a department, you can have many, right? Which violates. So therefore the best answer would be you take the department number, you put in the employee side. Right. And remember, when you have one to many, there are two possibilities again. Like in previous case, you can have foreign approach, which what we have discussed it here. Put in department number in the employee side. But then you can have a separate relation if you want. Okay, third one. When you have many to many relations, like works on, when you have many to many relation. So what you do is you create a separate relation, right? And include the primary keys of the both relations and combining it, you are going to create a primary key for the works on, right? So therefore, if you go back, you will see we are going to create a separate relation. It's called works on. We have works on relation here. And then we'll get the employee social security number from the employee, project number from the project. Combining the two, we'll create the primary key. And since number of hours are related to this relation, it also comes here. And this is how we will create. So just to summarize, when you have many to many relations, ideally you create a separate relation, combine the primary keys of the two participating entities to create the primary key of that relation, right? So make a note of that. Right, then the next one, when you have multi-valued attribute like this, you have to create a separate relation. So you can see department locations here and include the primary key and the locations information. Combining the two, you create the primary key. So that's how you work on multi-valued attributes. Right. Okay, so those are like general mapping ones. So I was assuming that you have already discussed this, but for the completeness, I have avoided this in the note, but I will include them, all the necessary details. That means from 1 to 7, I will include them again so that for the completeness. Okay, since we talk about the enhanced version, let me briefly discuss how do you map specialization and generalization we have just discussed. Right. Now going back to ER models, remember the very first thing that we have discussed here is superclass-subclass relations. And in this particular case, the characteristic is the job type. So based on the job type, employees can be categorized as secretaries, technicians, and engineers. So when you have a situation like this, we can create relations for each of these. That means for the superclass and all the subclasses. So notice here, we will create a relation for employee, and then we take the social security number as the primary key. And remember the characteristics also included here. And for all the subclasses, you create a separate class, right? And together with their specialized attributes. In this particular case, we have type speed, technician grade, and engineer type. So this is how we can represent. This is one way of designing or converting superclass and subclass relation. Right. Second one. Now let's say you have a superclass subclass relation. So the second design decision is when you have a situation like this, where this is very similar to previous one. You can create relation only for subclasses. Okay, here's a superclass, here's a subclass, right? So you create relations only for subclasses. So when you're creating relations only for subclasses, you include all the attributes coming from the superclass. So therefore, you create a relation called car. You will have vehicle ID, price, license plate number coming from vehicle. And then the other specialized attribute, max speed and number of passengers. And then you select one of the key attributes as the primary key. In this particular case, we have selected vehicle ID. Similar to truck, also we create a separate relation and you include vehicle ID, price, license plate number, number of axles, tonnage, and then you selected a vehicle ID as a primary key. Right. So two design decisions. What are the two decisions? First one, you create relations for all the superclass and the subclasses. So this is what you have noticed. So when you're creating separate the superclass and you include all the attributes there and subclasses, all the specialized attributes, and then you get the primary key from the superclass. So that's how you create relations for all the superclass and subclasses. Second one, you create relations only for subclasses. A third design decision is you can create just one relation for all the superclasses and subclasses. So look at this example. We have superclass employee, secretary, technician, and engineer. You are going to create just one relation for all the superclass and subclasses. So what you notice here is you include all the attributes from employee and you select the social security number as the primary key. And the characteristics, in this case, job type, and then all the specialized attributes, right? So this is how we can actually create the relation, just one relation for all the superclasses and subclasses. This is third design decision. Right, next. When you have overlapping, especially similar to the previous, but when we have overlapping stage, what do you mean by overlapping? I told you, when you take a particular part, it could be a manufactured part, it could be a purchased part, or it could be a both overlapped. So therefore, to implement this one, we are going to introduce special flags. So you can see here, manufacturing flag, here purchase flag. In a flag, you can have 0 and 1 to indicate whether this is belongs to this, right? If this one is 0, this is not a manufactured part. If this is 0, this is not a purchase part. So if it is only a manufactured part, you will have 1 0 here. We will have 1 0. If it is only purchase part, you will have 0 1. If it is both manufactured and purchase part, then you will have 1 and 1. So in this way, right, we can include all the cases, almost all the cases that you want to represent with overlapping. That means the parts could be a manufactured part could be a purchase part, or part could be a manufactured and purchased part. Hope you got the idea. Right. Any questions from this? So what we have discussed is, we discuss how do you map superclass subclass relation into relational model. And we discuss 4 different versions. Just to summarize, what are the 4 different versions? You can create relations for all. You can create relations only for subclasses. You can create just one relation for all the superclasses and subclasses. You can create a single relation with flags to indicate overlapping. Okay, if you have no questions here, we will have small exercise on how on implementing this. But let's move on to completeness, the last one. That means union categories. What do you mean by union categories? Okay, you have subclass and superclass. Here you have multiple superclass for a given type. This might be belong to one of the superclasses, right? Actually, it can be shared. That's the idea, right? And here is also same class. Now, when you have a situation like this, right? So you have to create separate relation for person, for bank, for company, which represent the superclasses. And this one represent the own ID, and then own ID will go to all these. Why we are doing this? Because depend on the situations, own ID could go into any of these. Could be a person, could be a bank, could be a company, right? And similar the vehicles as well. The registers vehicle could be a car or truck, right? And you can notice here, the vehicle ID will go to car and truck. The ownership relation, that means this one, is indicated with the separate relation by combining own ID and the vehicle ID. So these ones are normally we call surrogate keys, right? Which will implemented in this fashion, right? So that's all what I want to discuss under the relational mapping, right? So the basic ideas that we have discussed today is we discuss the relational model and relational model mapping. So that's basically what I have covered.